The central slip and the central slip insertion. As we discussed, the central slip is the central portion of the dorsal apparatus, and it coalesces and ends with a specific insertion into the dorsal base of the proximal phalanx. The middle phalanx. But this central slip cannot move independently. When there is any tension through the central slip, it is also transferred to the entire dorsal apparatus, and thus the entire dorsal apparatus would move in relation to this tension. The insertion at the central slip insertion does tether down the dorsal apparatus, limiting the excursion of the dorsal apparatus. The central slip and the oblique fibers both terminate at the central slip insertion. One therefore assumes correctly that they have a primary influence on proximal or PIP joint extension. That is indeed true, but they cannot do this in isolation. The remainder of the dorsal apparatus must move along with this at the same time. That is why the PIP and DIP joints always move together simultaneously. This tension moves the entire dorsal apparatus. And the transverse fibers are always tense. So I used the analogy in the first course of a concert, and each part and piece of the dorsal apparatus is a different instrument, but they have to play together. But at some points of the music, some instruments are more dominant than others, and others are more suppressed. I hope that's a useful analogy. Here we've highlighted the sagittal band, all of these moving in true concert. The central slip and its insertion is considered the primary extensor of the PIP joint, but it doesn't do really as extraordinary a job as you might expect. When the MP joint is hyperextended, there's no tension that remains to extend the PIP joint at this level. So we see the classic flexion contractures develop as a result of absence of the intrinsic muscles in the case of ulnar palsy. The central slip and its insertion, being a primary PIP joint extensor, also extends the DIP joint because of the interconnections we discussed in the first course. Whenever the PIP joint is being extended, the DIP joint is also being extended. They never move in isolation. The central slip insertion has a relatively limited amount of excursion. If we look carefully, here I have measured this piece of tape to be exactly 7.5 millimeters, and you can see it in relationship to my finger that this is how much excursion there would be at the insertion of the central slip. Obviously, there needs to be full PIP joint flexion and extension to move through this entire range of excursion. An important point is to appreciate the interplay between tension at the central slip insertion and tension at the terminal tendon insertion. If you will, in this schematic drawing, I've drawn it green to represent the lateral band and thus the tension distally at its insertion. If I take the finger that is resting and passively flex the DIP joint, I increase the tension on the lateral band. Because of these interconnections and because of all the fibers that are connected here, I then pull the lateral edges of the dorsal apparatus distally, and I am creating some slack at the central slip insertion. You may recall in the first course we talked about how in active finger extension, the lateral bands are the most active, and the central slip does not have much tension in it. This seems really opposite because we think about the central slip and its insertion really being the primary PIP joint extensor. This is food for thought as you sort through all of this information.